Okay, so in this video we're going to look at how sigma notation is used, and I've got a quick example here on the screen. So got this symbol which looks like a capital Greek letter sigma, and the sigma always stands for sum. So what that symbol means is to sum. And so this means that we're going to sum starting with I equals 1 and ending with I equals 3. And we're going to use the letter I in this expression. So when we write this out, we start with I equals 1, so we plug that into our expression for I. Okay, so here's the expression for I equals 1, and then we're summing, so we're going to add to that the same expression. Now we're going to up the value of I by 1, or increment the value of I by 1. Sorry, that should be minus. So this is the expression for I equals 2, and then we're going to add to that, we're going to up the value of I by 1, plug into the same expression. Okay, so this is for I equals 3, and the upper limit here is 3, so that's where we stop, and then we can simply add these numbers together. -1 plus 1 plus 3, 6 minus 3, so that would be 3. And that's really the idea of how the sigma notation works. So what the sigma notation will let you do is express some sums, express a sum more concisely and neatly. So a common sum that we see expressed with the sigma notation is the sum of the first n positive integers. And so this can be expressed nice and neat as the sum as I goes from 1 to n of just I, right? It's start with 1, then go to 2, then go to 3, and stop when you get to n. And in fact, there's an equivalent form to write this sum, and it can be expressed as n times n plus 1 over 2, right? So why would we want to know this? This is used a lot, very useful in math and computer science. So for instance, if you wanted to know the sum of the first, say, 50 positive integers, right, rather than write this out, we could certainly do it. Write it out: 1 plus 2 plus 3 plus 3 plus everything up to 50, and we could add 1 plus 2 is 3 plus 3 is 6, so on and so forth. Or we can just use this formula where we know that n is 50, so that'd be 50 times 51 over 2, and if we multiply that out, of course we could divide 50 by 2, that would be 25, so that's the same as 25 times 51, which is 1,275. So of course that's a little bit easier using this form for the sum, and that's a very common formula that you see used in math and computer science. Another common formula is the sum of the first n positive integers squared. And so this would be the sum as I goes from 1 to to n of I squared, and there's a nice formula for that one as well. Not quite as simple, but still simpler than adding up all those numbers. N times n plus 1 times 2n plus 1 over 6. So that's another commonly used and useful formula. Right, so those are some places where you see the sigma notation used. Maybe I'll look at one more example. Sometimes you see a double summation. So you might see something that looks like this. Okay, so you've got a sum within a sum. And notice the outer sum uses the letter I, inner sum uses the letter J. In general, those need to be different letters, although it doesn't matter what letter you use. So the way you do this is you start with the inner sum first. So just leave that sum I goes from 1 to 3 alone. Right, and first we're going to plug 1 in for J. Add to that, and then plug 2 in for J. Right, so all this stuff is now inside of that outer sum, and we can just simplify a little bit before we apply this outer sum. Be what I plus I is 2I, and then negative 1 minus 2 is minus 3. And actually that was an accident, but I think that turned out to be exactly the first sum that we did. Right, so let's say we forgot about that. Now we would just apply the regular sigma notation like normal. Again, we already did it because that was my first example, but so we'd plug in 1 for I, then we plug in 2 for I, and then we plug in 3 for I. So again, that's negative 1 plus 1 plus 3, which is 3. Okay, so one place this might be useful is if you were wanting to analyze some kind of loop structure in some program or algorithm that you had. For instance, you might have some kind of code, so maybe you have some code in here, and then you come to some kind of loop for I starting at 1 and going to n, and then inside of that you got another loop for j going from 1 to some other variable, maybe k, and then who knows, some code inside of this loop. Right, well, one way you could analyze something of interest might be, well, how many times would we execute this loop? How many times would the stuff in here get executed? And you could set this up as a sum. Your outer sum, you would take I from 1 to n, and your inner sum, you would take j from 1 to k, and then of whatever was in here, you might have to think about how you would express that. So of some stuff, whatever that might end up being. Right, we don't know. I didn't do a great job, I suppose, of preparing a specific example there, but certainly you can set up for loops mathematically using the sigma notation this way. So the sigma notation is used a lot, and very useful in math and computer science.